This is an AQA GCSE chemistry question from the Trilogy 2019 paper, and it's a higher tier question. In this video, we're looking at a question on bonding and chemical calculations, and I'm going to recommend you pause, go through the question yourself, and then review. So here is part A, part B, part C, part D, part E, and finally part F, 11 marks in total. So let's take a look at part A. A kilogram mass is made from a platinum and iridium alloy. It's harder than pure platinum. Explain why alloys are harder than the pure metal. So you do need to remember that metals have a regular structure. Now in an alloy, we've got atoms of different sizes. That will distort the regular layers that exist in pure metals. And because the layers are distorted, they can't slide over each other. For part B, a kilogram mass consisted of 900 grams of platinum and 100 grams of iridium. What was the ratio of platinum atoms to iridium atoms in the alloy? Don't fall into the trap of just comparing the masses, 9-1. We're given masses and we've got MR, so we need to look at molar quantities. So PT, platinum, 900 over 195 gives me 4.61, and 192 or 100 over 192 gives 0.52. I want a whole number ratio, at least one of them to be a whole number. So let's divide both of them by 0.52. That gives me 8.86 to 1. So we have our correct answer here. Part C, what's the value of Avogadro's constant? 6.02 by 10 to the power of 23. Straightforward factual recall. Part D, scientists could use a sample of silicon to define the Avogadro constant. Copper is an impurity in the silicon sample. There are 70 nanograms of copper in 1 gram of the sample. Calculate the mass of copper in grams in 1 kilogram of the sample and give your answer in standard form. There's a lot to think about here. 70 by 10 to the minus 9 tells me how many grams there are, but I want kilograms. So that is multiplied by 1,000. So I get 70 by 10 to the minus 6. And then I convert to standard form, 7 by 10 to the minus 5 grams. Part E, silicon mainly occurs in the Earth's crust as silicon dioxide. We've got the diagram here. Determine the empirical formula. Now the easiest way to do it is count up the silicons, count up the oxygens. I've got 16 and I've got 8. So I've got 8 Si, 16 O2. Simplest ratio is SiO2. And to finish off, describe the structure and bonding in silicon dioxide. Well, it's a giant lattice, as we just saw. It's non-metals. So we're thinking about covalent bonds, but it's not just covalent bonds, it's giant covalent. So there are lots of strong covalent bonds, and we need all of that information to get to the 3 points. And that takes us to the end of this question.